Alright, this section is going to be pretty short, and I'm going to keep it as short as possible so that we have more time to talk about it and do examples in class. So this is going to be using molar mass, which we did last semester, okay, and our balanced chemical equations. So this is called mole-to-mole ratios. So the coefficients, the large numbers that come before the different compounds in a balanced chemical equation, also tell you the mole ratios of the reaction. So here's an example of a balanced chemical reaction. We have two magnesiums reacting with one molecule of O2 to produce two MgOs. Okay, so we have basically magnesium here is reacting 2-to-1 with the oxygen. Okay, and then, whoops, didn't need to hit that. Two magnesiums will also produce two magnesium oxides. Okay, one oxygen molecule will produce two magnesium oxide molecules. All right, so basically it's a 2-to-1-to-2 ratio. Okay, so we can use this if we are given, say, the mass of magnesium that we're starting with, and then we're reacting it with the oxygen in the air. We can actually use that mass of magnesium using the mole ratio to figure out what mass of magnesium oxide we should expect from that reaction. Okay, we can also use it to figure out how much oxygen we'll have to react with the magnesium. Okay, so let's get into an example of this. All right, so we have our balanced chemical equation here. 3H2SO4 plus 2 aluminum yields 1 aluminum sulfate and 3 hydrogens. Okay, so it's hydrogen sulfate plus aluminum yields aluminum sulfate and hydrogen. So with these, it's really important to always start with a balanced chemical equation. Okay, so that's why I wanted to make sure that y'all had a chance to go through the balancing chemical equations to understand how to do that. Okay, so you always need to start with a balanced chemical equation. And then you can use your mole-to-mole ratios to compare moles of any compound in the equation to moles of any other compound that's also in the equation. Okay, so if I were just looking at aluminum to aluminum sulfate, so we have our aluminum here and aluminum sulfate. That is a 2-to-1 ratio. Okay, if I were looking at the hydrogen sulfate to aluminum, it's a 3-to-2 ratio. Right, hydrogen sulfate to hydrogen, 3-to-3. Okay, or 1-to-1. You can simplify it that way too. Okay. All right, so now we're going to get into some of the calculations here. Okay, so I can show you actually how to use this. And it's relatively simple, okay? Just remember these are mole ratios, so in order to do these calculations, you actually have to have your numbers in moles. Okay, you can't do it with grams. You have to convert from grams to moles. Okay, so you have 3.4 moles of aluminum. How many moles of hydrogen sulfate do you need to completely react with the aluminum? All right, so we are given our 3.45 moles of aluminum. All right, so now we need to figure out how many moles of hydrogen sulfate are going to react with that aluminum. So you need to watch your units in this, okay? Now, we have our hydrogen sulfate here is a 3, and our aluminum is a 2. So we have a 3-to-2 ratio, okay? But which one is going to go on top and which one is going to go on bottom, right? I always remember by saying the one I'm going to goes on top, the one I'm coming from goes on the bottom. But if you forget that, remember, you have moles of aluminum to start off with. So you're going to have to cancel that unit of moles of aluminum. So you need moles of aluminum on the bottom. Okay? And then if you look back at your chemical equation, your balanced chemical equation, that would be a 2. Now you're going to moles of H2SO4. Okay? So that will be 3. right? That's because it's a 3 coefficient. Okay, so you're going to have 3.45 times 3 and then divide that by 2. And that's going to give you the number of moles you need of H2SO4 in order to completely react with the aluminum. So that works out to 5.175 moles of H2SO4. Now if you had, or if you wanted to calculate the molar mass, you could figure out the number of grams of that. Okay, so you know how much mass of each of your reactants you need to completely react with each other without leaving excess over at the end. Okay, so you're not wasting materials. Alright, so let's look at continuing example on this one. If you have 3.45 grams of aluminum, how many moles of H2 will be produced in the reaction? Given that aluminum has a molar mass of 26.982 grams per mole. And then a second question is how many grams of H2 will be produced, it's supposed to be given that H2 has a molar mass of 2.016 grams per mole. So this is kind of what I was talking about, where you can start with grams and then go to moles and figure out the mole-to-mole ratio, right? So let's do our first question. Okay, we're trying to figure out the number of moles of H2 that will be produced in this reaction. Okay, so we start with our 3.45 grams of aluminum. We need to convert that to moles, so we have our conversion factor right here. Remember, grams go on the bottom so that they cancel. And you've got your 1 mole on top, and this is still of aluminum. So our grams of aluminum will cancel there. And now we're to moles of aluminum. So now we need to figure out the number of moles of H2. So we're going to moles of H2, so that's going to go on top. And then we need moles of aluminum on the bottom. Okay? So we've got moles of hydrogen right here. That'll be a 3. Moles of aluminum right here. That'll be a 2. Okay? So you've got 3.45 divided by your molar mass, which is 26.982. And then you're going to multiply that by 3 and divide it by 2. Okay? So you end up with 0.192 moles of hydrogen. Okay? So that's your first answer. Now the second part is asking you how many grams of H2 will be produced given these conditions. So you're still starting with this 3.45 grams of aluminum, okay, which produced your 0.192 moles of hydrogen. So because we're taking that number of moles to grams, we only have to do the one additional step. So it's 0.192 moles of H2. And we are given the molar mass here. So grams will go on top this time because we have moles and we need to go to grams. So that's grams of H2. And then we have in 1 mole of H2. So moles of H2 will cancel, and that will leave us with 0.192 times 2.016. Okay? So we end up with 0.387 grams of H2. All right? Now, I know I only did one example with this, but we're going to work on this more in class. So you'll have more time to work through these. I'm not going to focus on can you calculate your molar mass right now. Just going to focus on can you set up these equations correctly, and then can you actually perform the equation or the calculations. Okay? So that is the end of this section. If I can get to